I'm so pleased to be able to introduce Sanjeev, payments legend with experience across Broadcom, Visa, Meta, and now GoFundMe. And in particular, we were just talking a minute or so ago, and Sanjeev was part of the team at Visa that wrote the first line of what network tokens look like as a specification and went through all the way to seeing them being deployed, right? So I think I'm hugely looking forward to learning from him. And Sanjeev, thank you so much for speaking for us.
Thank you, guys. I think first question, how many of you heard network tokens? Okay, that's cool. So if you haven't heard network tokens, most likely you have used network token. How many of you use Apple Pay or Google Pay? Or any like Netflix? So if you have used any of those services, you have used network token, whether you know it or not. So before I go into network tokens, let me just do a basic background and why is it important. First, let's categorize the payments, like what type of payments and related frauds we generally deal with. There are many ways to dissect how the payment needs to be categorized, but the simplest way to categorize payment would be, which a lot of payment people talks about, is card present, card not present. Card present transactions are a transaction, you go to the store, you physically either dip the card, tap the card, or swipe the card, in-store transactions. So those are known as card present transactions. And then there is second category which is called card not present, which means like all your e-commerce. So technically it should be card holder not present, but it's called card not present. So all online transactions, they are called card not present transactions. So now we know the two basic domains of the transactions. Now let's talk about the fraud corresponding to those categories. So one of the most common fraud is called cross-domain fraud. What cross-domain fraud means is the hacker or some bad actor stole your card information in one domain and then goes to some other, like one of those two domains, and use it. For example, you went to a restaurant, you gave your card to somebody. In US, even now, sometimes they take the card back with them. They can just simply write it on a piece of paper, your card details, and then can go home and go online and buy stuff for you. So this is the number. Cross-domain fraud is the biggest fraud. Like almost 70% of the fraud in the industry comes in the cross-domain fraud. Then there is something called same-domain fraud. In same-domain fraud, you steal the credentials in the domain and you continue to use in same domain. So like say you somehow stole the card by maybe data breach or something on a card not present world and use in card not present world. So maybe you somehow stole the credentials and then make a card out of it, and then go to the store and then use it in the store itself. That was popular during the MaxStripe days. It is very difficult to do it now. But in MaxStripe days, you could literally somehow skim the data and then make a card out of it. And then you can go to any store and use it. And the reason being is MaxStripe data, which is on the magnetic strip on the card, is very static data. There is nothing uniqueness in any transaction in terms of card credential. It's static data. Every transaction made using that credential will contain the same payment credential data. So if you have it, you can replay those transactions, those credentials, and make a payment. And so over time, this industry is not new, and I think I should have mentioned earlier, we're going to focus mostly on cards here. Payments cover many other payment methods, but this talk is mainly around card payments, just to set the context. So over time, there are a lot of mitigations this industry has come up with to reduce fraud. And I'm going to talk about few, and then I will move on to network tokens and how network tokens are going to helping mitigate risk even further. So one of the big innovation came on a chip cards. So chip cards have reduced the in-store fraud significantly. And I think there was a lot of talk about chip and everything before my talk. The benefit of chip card is like there is a cryptographic key stored in the card, and every transaction has a unique data in it, which means you cannot replay the transaction. Even if you steal the credentials, you have to have that dynamic data associated with the transaction to use for the new transaction. So even if you stole my data, if you try to replay the transaction, it won't work because the data, the dynamic data has to be unique. If you steal my transaction and use the same data for the next transaction, it will fail. So every transaction has a unique data, which means that the or the same domain or same channel fraud, at least in the in-store, was completely destroyed or eliminated by chip cards. And before chip card, during the max type days, that was pretty common to have the in-store fraud because of the static data. And for the CNP world, we have seen the rise of a lot of transaction monitoring and fraud services, which help which helps determine if this is a fraudulent transaction or not. And those services are based on behavioral device fingerprinting, and the talk before my talk was about passkeys and 3DS. So those technologies and those components came in and reduced the fraud, but still, it is still high. And industry is still working on coming up with different options or different methods to keep reducing the CNP fraud. The in-store or the CP fraud was pretty much mitigated using chip cards. So wherever we still have magnetic cards, there is still a possibility of doing those frauds on an in-store, but the amount of fraud on the card present world has gone down after chip cards introduction. So let me give another background on network tokens, then I'll move into the main topic of this talk. What is network token? Network token is a surrogate value of PAN. So let's say you're writing a card on an Apple Pay, you will enter your PAN number, and then it goes to the network being Visa, Master, Amex, or other schemes. They will generate another card number, and they will link it with this PAN. So this credential, which is called network token, is digitally issued. So it is not printed anywhere, it is not known to anybody, it is only known to this wallet who's requesting this network token. So network token typically has the same format as a PAN. So it will still be the 15-digit number or 16-digit number, like Visa, MasterCard is 16-digit, Amex is 15-digit. So the format is still the same like PAN. And the reason the format didn't change, because if the new format would have been introduced, all the merchants have to make the changes to accept new format, which would have taken probably more than a decade to adopt that technology. So we made a decision, let's not change the format, let's just create a new value, and it's digitally issued value. And the rules were made that these wallets cannot expose the entire value to anyone. You can show the last 4 for customer service, but other 12 digits should not be shown. So that made it a little bit secure as compared to PAN. Typically, a PAN or your plastic card will have multiple tokens. And the reason being is, if you have multiple wallets, you'll get a unique token for every wallet. So let's say if you have Google Wallet and Apple Pay wallet as well, for the same card, if you add it in your wallets, you will get different token for Apple Pay, different token for Google Pay. So multiple tokens associated with one PAN. Other way is not possible. One network token cannot be linked to multiple PANs. So there's one-to-end relationship. And what happens is, when the transaction goes to the network or the bank, based on the network token, ultimately what they do is they find out which PAN it is associated with, and they run all their logic of authorizing the transaction on PAN, because that's what their system is coded historically. So they didn't have to make any change. Network does the mapping from network token to PAN, and issuer just keep processing with the PAN. So that enabled the industry so that the merchants are not impacted, issuers are not impacted, all the hard work or the technology built around the network tokens were in the network space, or the Visa or MasterCard. The banks and merchants were kind of isolated from that. That helped the adoption of this technology. And typically when a token lifecycle management involves provisioning of a token, which means you just add it in a wallet and then you get a network token. You can delete the token. You can also suspend the token. Only banks can suspend the token, wallets cannot. Let's say you call the customer service and say, I lost my phone. Can you just suspend my token? Uh, you have two options. Either you can delete the token through the issuer, or you can just suspend the token, and once it's suspended, it can be resumed as well, or it can be deleted. But the beauty of this is all electronically, it's all programmatically controlled. You don't have to physically mail a card or physically mail some digit or some letter that, okay, you're getting a new card. The problem with the PAN is or the plastic card is if you lose it, issuer has to send it to you. And there is a friendly fraud possible there. If somebody gets hold of your card and they know enough details about you, they can call the bank and activate that card and use it for the wrong reasons. But in case of digital issuance, it happens instantly, and then generally issuance is backed by some kind of authentication, which we talked about earlier, like 3DS or passkeys. So that unless you pass that authentication, that token will not get activated. In some cases, especially in e-commerce world, some of the tokens are generated behind the scenes, especially, let's say if a merchant has a lot of card on files and they are switching from cards to network tokens, they do a bulk network tokenization. At that time, customers are not present to authenticate, so only those scenarios are enabled without authentication, but all other scenarios like Apple Pay and Google Pay, when consumer is or the cardholder is adding a card, they go to authentication. So with only the CNP tokens are the tokens which don't go through authentication, but all the card present or the device tokens, they go through authentication before they get enabled. So this is the main topic. How does network token reduce the fraud? So if you remember in the very first slide, I said cross-domain fraud is the biggest source of fraud. So what networks did, when they assign a network token, they assign it to one domain. I'm creating this token for, let's say, card present world. I'm creating this token for card not present, which means even if somebody steals this card, they cannot use it across domain. Let's say I have my Google Pay wallet here. Somehow, some hacker, there's a lot of smart people here, steal my data from here. And then they go online and try to use the same token to buy something, it will be declined. Because this token is bound to a device for card present transactions only. So that eliminated the entire cross-domain fraud, which is the biggest source of the fraud. So that was one of the biggest benefits we got from the network tokens right away. There are, just an exception, there are certain tokens which are allowed on both domains, which is Apple Pay tokens, because they are claiming that my device is pretty secure. So let me use the same token for both card present, card not present. But most of the other tokens, they're domain controlled, either card present or card not present. So as I said, this eliminated the biggest fraud, source of fraud cross-domain. Now the other fraud I talked about was same domain. The same domain fraud was reduced by network tokens by leveraging all the security measures a chip card had. So whatever protocol or data gets exchanged for chip card, same data is used for network tokens as well. And if you remember, I said chip card, every transaction has a unique data. Same with network token. If you're paying with network token, if you go and tap your wallet, every time a unique data gets, each transaction has a unique data, which means a transaction cannot be replayed. So that even if you steal my credentials and try to go to the store, it won't work because of the dynamic data. So that helps reduce the same domain fraud. I think one important thing I should mention here is how the credential gets stored. Because if somebody steals my card number, the token number, and the key, they can potentially start generating the dynamic data the way banks expect anyways, which means you can do the fraud. You can, as far as I can steal your card number and the cryptographic key. Apple stores those key and card number in secure element, which is same as the chip you see on a card. A SIM card is pretty much like a secure element is like a SIM card. So Apple has a dedicated chip where they store this data. I'm sure there are a lot of people around this floor trying to break that chip, but still it's pretty secure chip, and because of secure element, because Apple is using the secure element, it is pretty safe, and that is the reason why banks were okay to allow both card present and card not present transaction on those tokens, because the secure element is backed by your Face ID or by biometric, which is proved to be pretty secure so far. So Apple is storing the data there, which allowed them to get static key, which means once the card is provisioned, a network token is provisioned, they get the network token and a key. And that key is static, which means as far as the network token is valid, this key is valid. So they can keep on generating as many transactions as possible using that same token number and the cryptographic key, because it is securely provisioned in the device. In case of wallets on Android, they made a decision, I forgot the exact number, starting 2014, that the key can be stored in a device memory. The credentials can be stored in a device memory, which means there is a possibility of hack because it is stored in a volatile memory. There are a lot of new technologies that have come up, secured enclave and some secure memory space, but they're still in a space where it potentially can be hacked. So in that scenario, issuers were a little bit skeptical whether they should allow the tap and pay transaction on this Android platform who's storing the credentials in a memory. So in order to manage the risk, what networks came up with is, okay, fine, this token number will go in there, we will provision a key, but let's limit the usage of this key. And the way it could be limited was like it could be a single use key, which means you make one transaction, then you have to get a new key. Or it could be you can make 10 transactions, then you have to get a new key. Or it could be you can spend $1,000 on this key. As soon as your cumulative spend on this key crosses $1,000, you have to get a key. Or it could be time to live. If this key is only valid for 10 days. Whether it's used or not, if it is more than 10 days, get a new key. By doing so, what we did is reduce the scope or reduce the amount of fraud a person can do, even if you steal the key. The maximum, let's say, is $1,000. The maximum damage to the bank will be $1,000, or maybe 5 transactions, or whatever that amount is. And payment is nothing but managing the risk. So banks were comfortable that as far as I have a power to limit how much money a cardholder can spend on a given key. I'm very comfortable with this. Hence, they adopted the whole Android proposal of storing the keys in a memory. So now network tokens were designed to eliminate the cross-domain fraud and reduce the same domain fraud. Sure. So the question from Vincent is like all these controls on the value of the key, who controls that? So without revealing which network does what. So these are the different options. Different networks use different options. Some networks use single use key. Some networks use one key can have multiple transactions. This by the network, but most of the time it is what the values will be decided by the bank. So they can also do is, depending upon the portfolio of this card, they can have a different value, because every bank has a different portfolio. There's like a high network worth, or there's a classic card, signature card for Visa. So they can control the amount of flexibility they want to give on key based on the risk profile of those cardholders. So they are the one who's going to design, they decide what the value should be. And one of the reason why it is like not single, a lot of people didn't go with single use keys, because sometimes you may end up in a situation where there is no cell signal and you are trying to buy something, but you're not able to refresh the key. So let's say you go in a subway station, it's the middle of the night, you tap your device, you bought something, let's say some food, the whatever single use key you had in the phone is already used. Now you go to the train station, try to get in, you won't be able to get in because the key is not valid. So for that reason, a lot of the issuer went with, let's allow few transactions, especially in the case where somebody is stuck, they can at least pay and move on. Okay, so now the network tokens, so far I talked about help reduce the fraud in the CP space, or card present space, by reducing the cross domain and also using the chip specs. Now, how does it help the card not present space? Because even with the chip card, if you want to use it online, you still type in the number, you still very static data. You still have the 16-digit number or whatever the number of digits card has. There is expiration date, there's a CVV2 or CVV, but so still static data. So what network tokens, the idea that network tokens came up with or networks came up with is, let's use the same idea of creating a dynamic or unique data for each transaction, even for card not present. And the way card not present unique data can be generated, if there is a key associated with it, generally in a device-bound token or a chip, the key is provisioned with the token. In a card not present token, the key remains in the cloud with the network. So now what happens is, every time a merchant wants to transact using this network token, they real-time reach out to the network, generate a dynamic data for me for this transaction. So what networks do is, using the same key, they generate a cryptogram and then send to the merchant, and then merchant submits the transaction through the normal route for approval. Now once the transaction reaches the network, they can verify the same cryptogram and making sure that this cryptogram is valid, and also this is submitted by the same merchant who got this cryptogram. So the benefit of network token in CNP world is that they introduce this dynamic part of the transaction for CNP as well, which was missing earlier. Earlier it was like without network tokens, with the PAN number, it is only the 16-digit number and CVV2, which is not dynamic. It's the same value which is printed on the card. So using these techniques, network tokens are able to reduce the fraud. And other thing which helps on network token, as I said before, network tokens are not visible to anybody. So nobody knows the exact value of network token. If a cardholder knows the value, they may write it down, somebody can steal it. That's not possible. So just the very fact the network token value is not visible makes them a little bit secure. And the other part which is important is, every operation you do on network tokens, whether you provision it, whether you get like a cryptogram for the CNP transaction, it goes through a typical network security. If I'm a merchant, if I have to provision a network token, I have to call the network, which means I have to present my API credentials. I have to prove that I'm a valid, approved token requester, approved and vetted by the network to get a token. So I have to go through my API key authentication and all that. Even to get a cryptogram from the network for a CNP transaction, I have to go through the same API credential, API authentication, which means every interaction with the API key with the network goes through additional security of network level security. So based on all these different controls put in place, network tokens are a little bit safer to use. I'm not going to say this is 100% foolproof, but they have, as you can see, MasterCard did some studies. The fraud has come down by more than 50% because of all these controls put in place. And just a quick reference on, like, if I compare how the PAN and network token works, as I said, PAN is static. Same digit for the number, same digits for CVV2, and same digits for expiration date. Network tokens are using the dynamic data, plus the card works everywhere else. Like same card works in every merchant, same data is used across the merchant. But when we use network token, it is bound to a device, it can be bound to a merchant, it can be bound to one transaction. Since it's a digital transaction, there's a lot more controls can be put in place, depending upon what merchant wants, what network wants. The key part is this. The breach surface on PAN is pretty high because same PAN is stored at multiple places. If breach happens with one merchant, you are exposed. Now the same card can be used anywhere else. If my card gets stolen from one merchant A, which means other merchants are also exposed now. because they know now the card number is known and it's static data. With network token, even if somebody breaches the data, let's, for example, ABC merchant, if ABC data gets stolen, and the network token stolen from ABC cannot be used anywhere else anyway. So no other merchant is impacted from that. Even for the banks, it's easier to manage because they don't have to physically mail a new card. They can simply just delete these digital tokens and generate new ones for ABC. So the cost of maintaining the cards and making sure their cardholders still have the right credentials decreases significantly, because every time you mail a card, the banks spend like $20 or something just to go through the printing the card, mailing the card, authenticating the card. It's a very expensive affair. But with not network tokens, they can delete, generate new tokens on the fly. And what else I should talk about? I think this is pretty much it. I talked about everything. Any other question? Like, if I had to summarize it, I would summarize the main reason network tokens are more secure because they are more dynamic as compared to PAN, especially for CNP transaction, and then they are digitally controlled. There are networks and issuers can put a lot more domain control, lot more controls on those digital credentials as compared to PAN, because PANs are designed to work everywhere. Once you have the PAN on file, you can use it anywhere you want. But with with network tokens, they have a benefit of limiting how and when and what they can be used for.
Could you give an example of when a network token would prevent fraud with card not present and with card present? And also, could you also tell me, is this similar to or different from Auth SDK or something like that used by digital payment providers? Yeah. So how are network tokens preventing fraud? Like an example of that. For example, if somebody stole a card and then tried using the card in a store, wouldn't it still work? And if they tried using that card on eBay, why wouldn't it work? Thank you.
So if the person used the PAN, then it will work. But if, let's say, somebody stole a network token credentials, I'm a merchant, let's say ABC merchant, somebody hacked my server and they stole all my network tokens, corresponding expiration date as well, and they try to use it any other merchant, it won't work because the request has to come from them. So that's how they were able to prevent the fraudulent transaction using network tokens. But if somebody steals the card and then tries to use the card again for transaction, it's a different fraud vector.
And the other question was about
Is that that's different. So first of all, tokenization is not a new concept. All the acquirers had the network token. All the acquirers had the tokens as well. So if you think about Stripes and Ardians and Checkout and CyberSource of the world, they also have the token. But the problem with their token is it is only going to work with that PSP or that processor. Network tokens are more open loop and compatible across all the PSPs. So if you have the network token, you can process with any PSP. It is not tied to one processor or one PSP. Any other question?
So the backwards compatibility of like reusing the address space of PANs seems pretty clever, but is there any risk that we run out of that address space?
It is a valid concern. Even before network token came in picture, there is a concern that the networks will run out of those 16-digit numbers. And network tokens made it the problem even worse because issuing card is still slow, but generating tokens, deleting tokens, generating new ones is much faster because it's digitally controlled. So what banks did, at least I can talk from Visa perspective, the Visa went back to all the net banks that we have allocated so much space to you in terms of 16 digit. You're not using most of it. So whatever you're not using, give it back to us so that we can use it for tokens as well. But having said that, there's a lot of effort going on from moving from 16 digit to 19 digits. So once the industry will move to 19 digits, suddenly the space will open up. And then I don't know, maybe there's a world when more alphanumeric card numbers will be there as well. But for now, it is still digit based, and industry is moving towards 19 digit. In fact, if you heard, typically a six digits called BIN for a bank identifier. Industry is moving towards 8-digit BIN, so that they can cover more issuers using eight digits. So if 8-digit bins and 19 digits span, that will open up a lot of space.
You associate the PAN with the network token. I mean, how do you transfer these to person? If I go to a store to use the PAN, how can I associate myself with a network token?
So when you add a card, either on an e-commerce space, let's say you add a card on Netflix, or you add a card on Apple Pay, at that time, these merchants or the wallets like Apple Pays, Google Pays of the world, they reach out to the network and a bank that someone is trying to create a network token for this PAN. Now the bank does a decisioning whether I give you the token right away, or you know what, I will create a token, but I will authenticate my user first before I activate this token. So they will send you some authentication mechanism. It could be a one-time password. It could be they will call you from customer service, or they may ask you to log into the banking application to authenticate that you are the one who's requesting this network token to be created. So then that's why it gets associated with that PAN and you.
My question comes from word versus. It's not actually versus. It's a complementation. You're using PAN with the new transaction token. It's a way of implementation. They're using it as a new PAN, right?
Can you repeat the question?
No, my question coming from the versus of this slide. I mean, there is no versus. It's you using PAN with implementation network token to generate the transactions using the PAN as identification, right? So you are assigned with the PAN.
Yes.
And you use the network token to use the PAN to make the transactions using the network. That's my question. Using the versus of the slide make me the question. That's why I asked that. It's not the versus. It's a complementation.
Yeah, it's not a question. You are creating.
It's an association. It's a mapping.
Yeah. So it's like a pointer to a PAN.
Sorry, I have one question.
Please go.
How do passkeys kind of play with this idea of network tokens? Are they like entirely different concepts?
I think this is entirely different concept, but it can be used to authenticate the user. So whenever, I don't know if you remember when you added a card in Apple Pay last time, generally banks will step you up before they enable that token. So now, if the passkeys are enabled, then that could be another way to authenticate you versus sending you a OTP or you call customer service to authenticate. So they're kind of orthogonal, but can be used together to create more secure provisioning of the token. Okay, that's it.